In this video, we will discuss the questions of IMET Maths 2023 series. First question is 48. Consider this function defined for every x greater than 1. Note this point, where ln indicates the natural logarithm. That is, ln implies logarithm with base e, and function is fx is equals to 2 time of log x minus 2 time of log of x minus 1. Which of these is an expression for its inverse function f inverse y? Okay. Now work for given question. First of all, we have given that x is greater than 1. Question is 48. And ln means logarithm with base e. And we have given that fx is equals to 2 time of log ex minus 2 time of log of e x minus 1. Now this can be written as fx is equals to 2 time of log of ex minus log of e x minus 1. Now after this step, we know that log of x minus log of y, this is equals to log of x upon y. Just using this property, this fx can be written as 2 time of log of e x upon x minus 1, and we have given that also x is greater than 1. Now actually in this question we have to comment on inverse function. So if we have this function fx, now let y is equals to fx according to given data. This implies that y is equals to 2 time of log e x upon x minus 1, where x greater than 1. Now this can be written as y upon 2. Y upon 2 is equals to log of e x upon x minus 1, where x greater than 1. Now for this equation, take exponential on both sides. We get e of y upon 2 is equals to e upon x minus 1, where x greater than 1. This implies that e of y upon 2 equals to x upon x minus 1, where x greater than 1, where e log e, any number, suppose x, which is equals to always x. This implies that e of y upon 2 x minus 1 equals to x. E power y upon 2 into x minus e power y upon 2 equals to x. This further implies that e y upon 2 x minus x equals to e power y upon 2. X common out, e y upon 2 minus 1 equals to, now come to further steps. This implies that x is equals to e y upon 2 upon e y upon 2 minus 1, and we know that we consider y is equals to fx. And in this question, inverse function concept arise. This means that this function is 1 1 plus 1 2. This means f inverse exists. If f inverse exists, this means it's also function. Now for this equation, just apply f inverse on both sides. f inverse x. This is equals to f inverse y equals to what? This f inverse f of x, which is equals to x. So using this and this, we get f inverse y equals to e power y upon 2 e power y upon 2 minus 1, where x is greater than 1. Now come to options. Option C incorrect, option D incorrect, and option E incorrect. Option A and B are similar, but conditions of Y are different. Now we have to work for also this. Again, as x is greater than 1. Notice this point. And we know that x upon x minus 1. This can be written as 1 upon x minus 1 upon x. Okay. This also can be written as 1 upon 1 minus x. Say this equation first. We know that x greater than 1 also less than infinity. This can be written as 0 less than 1 upon x less than 1. This implies that 0 less than minus 1 upon x greater than minus 1. Now in this equation, add 1 on all both sides. 1 upon 0 greater than 1 minus 1 upon x greater than 1 minus 1 is equals to 1 minus 1 upon x greater than 0. Now similarly, this implies 1 less than 1 upon 1 minus 1 upon x infinity. This implies that 1 less than x upon x minus 1 less than infinity. Now to this equation, apply log on both sides. Log of 1, log of x upon x minus 1 less than log of infinity. This implies, in this equation we implies this log on all sides because this inequality remains same because logarithm function is increasing function. Okay, remember this concept. Now for this equation, we seen that log of 1 0 less than log of x upon x minus 1 less than infinity. Apply 2 on both sides. 2 into 0 less than 2 into logarithm of x upon x minus 1 less than 2 times of logarithm, which is equals to 0 less than 2 times of logarithm of x upon x minus y equals to y, and this equals to. This implies that y is greater than 0. Now come to again options. In option A and B, option A is more correct, so option B is incorrect. So for this question, option A is correct.